Hey everyone, welcome back to TechOps tutorial. In this video, we are diving deep into multi-container pod in Kubernetes. We will break down what they are, why you might use them, real-world use cases, and a simple diagram to help you visualize how everything works. By the end of this video, you will clearly understand when and why to use a multi-container pod instead of multiple single container pods. Let's get started. Alright, let's start with the basic. What exactly is a pod in Kubernetes? A pod is the simplest deployable unit in the Kubernetes ecosystem. Think of it like a wrapper that holds your application container or sometimes more than one and provides everything it needs to run. Most of the time, a pod runs a single container and that's often enough for many applications. But here is the key part. All containers in the same pod shares the same network namespace, which means they can talk to each other over localhost. They can also share a volume so they can access the same files if needed. In this diagram here, you can see a single container running inside a pod. This container can access shared network, shared storage, and the same Linux namespace as other container in that pod if there are any. So basically the pod acts as a logical host for container, giving them a common environment to work together. Now let's talk about multi-container pod in Kubernetes. By default, most pod run just one container, but sometimes we may want to run multiple container inside the same pod, and that's where multi-container pod comes in. These containers aren't just sitting next to each other, they are actually working together. Think of it like a roommates sharing the same apartment. They use the same kitchen, bathroom, and the Wi-Fi. Inside a multi-container pod, all the containers shares the network so they can talk to each other using localhost, just like how apps in the same machine communicate. The same storage volumes, useful if they need to read-write files together, and the same lifecycle, they start and stop together as one group. In the diagram here, we see two containers shown, but in real scenario, a pod can have more than two if needed. Though it's best to keep the number small for better management. Multi-container pods are great when you have a containers that depends on each other closely, like a web server and a helper app that handles log processing or watches for file changes. We will see real example and use cases shortly, but for now just remember, use multi-container pods when your container needs to work as a team, not as an individual. Now let's talk about when you would actually use a multi-container pod in Kubernetes. You will see most of the time pod runs just one container, but there are special cases where it makes more sense to have a multiple containers working together inside a single pod, like a little team. So when should you consider using a multi-container pod? First, when the containers are tightly coupled, meaning they really depend on each other to work properly. A great example is when one container handles the main app and another one does logging or monitoring for it. Second, when containers need to share files or volumes. For instance, maybe one container writes logs to the shared volumes and the other container read and process them. And finally, when the container need to talk each other over a local host, since all containers in a pod shares the same network namespace, they can communicate like they are on the same machine using localhost. On the right, here you can see in the diagram, the single pod with 4 containers inside. They are all sharing the same common resources like storage, networking. This is great example of how multiple containers can work together efficiently inside a pod. But just a heads up, even though you can run several containers in a pod, try to keep it small and focused. Too many containers in one pod can become harder to manage and troubleshoot. So in short, use multi-container pod when containers are tightly connected, need to share a data or need fast local communication. Let's look at a real world example of when you would actually use multi-container pod. Imagine You have a web server that writes a log, things like a user activity, error, or a request. Now, instead of having a completely separate service to collect those logs, you can add a log collector container in the same pod. Here is how it works. The web server container keeps writing a logs to a file or a directory. The log collector container reads those logs from the same place and sends them to something like Elasticsearch or a logging system. Both containers are connected through a shared volume, which is basically a common storage space where one writes and other reads. And since they are in the same pod, they can also talk over localhost, making the communication super fast and easy. In the diagram on the right side, you can see a web server writing the logs, the log collector picking them up, and a shared volume connecting them, and the whole setup living inside a single Kubernetes pod. This is a classic use case of multi-container pod. One container does the main job and another container supports it, in this case by managing the logs. It's efficient, tightly integrated, and easy to manage, which is why this pattern is pretty common in real Kubernetes deployment. Now let's look at some common pattern used in multi-container pod. These are design ideas that help you to solve a specific problem by using multiple containers inside a single pod. Sidecar pattern. This is one of the most popular pattern. Imagine you have a main app container and next to it you add a sidecar container that helps with extra tasks like logging, monitoring, and backups. It's like adding a helper that rides along with your application. They both share the resource, and because they live in the same pod, they can work very closely together. Next is adapter pattern. This is a super useful when you are dealing with older apps that need to talk with modern APIs. You add an adapter container that transforms data formats or a protocol between the old and the new. So your legacy application talks to an adapter and the adapter talks to the modern world. It's all happening inside the same pod, clean and efficient. And the next is ambassador pattern. Think of this as a proxy. Your application wants to connect to an external service, but instead of connecting directly, it sends requests to the ambassador container, which then talks to the outside system. This gives you more control, security, and flexibility. And also lets you switch external service more easily without changing any main application. These three patterns, sidecar, adapter, and ambassador, are core building blocks in Kubernetes design. You will see them a lot in real-world setup. Let's bring the sidecar pattern to a life with a real-world example, an Nginx web server paired with a file watcher. On one side we have Nginx container. It serves static files and handles incoming HTTP requests from the user. Inside, it's configured to serve a content from a directory like /shared/www. Next to it, we have a file watcher container. This one monitors the same shared folder for any new files. So if a new file is uploaded or modified, the watcher can process it, maybe compress it, rename it, or trigger a script. The magic happens thanks to the shared volume. Both containers access the same directory, so they can cooperate smoothly without needing to transfer files between them. Together, they form a single pod. The Nginx container handles the front end while the watcher quietly runs in the background, enhancing functionality without touching the main app logic. This is exactly what the sidecar pattern is all about, extending your main application with a companion container that's add extra power. Now let's talk about what happens during a pod's lifecycle, especially how it starts, fails, and restart, along with how we handle the logs in multi-container pods. First is shared lifecycle. All containers inside a pod start and stop together. They are treated as one unit. So if the pod is up, all containers are running. If the pod is deleted, they are all gone together. But what happens if something goes wrong? That brings us to a failure behavior. If any part of the pod fails, like one container crashes, Kubernetes will restart the entire pod. All container inside it will go down and come back up together. This ensures everything remains in sync. Now let's dive into container specific log. In multi-container pod, logs are not shared across container. You have to target a specific container using -c flag. For example, if you run kubectl log pod name -c container name. This command lets you inspect the log for individual container like apps, matrix or logger. Finally, notice that when the pod is restarted, all containers, app, matrix, logger are relaunched. Logs reset, but you will often see startup message like application started successfully on port 8080. Useful for checking readiness. So just remember, pod behaves as one unit, restart together on failure, and their log must be accessed container by container. This is very common confusion, so let's clear it up. Multi-container pod is not the same as multiple pods. First, let's look at multi-container pod like this, one with a web and a logger container. They share the same lifecycle, they start and stop together, communicate over localhost, since they live in the same network namespace, shared volumes, meaning they can read and write to the same data files. But there is no way to scale them independently. If you need more logging, you scale both web and logger together. Now let's see with the two separate pods, pod A and pod B, each with a single container. These have an independent lifecycle. They can start or stop separately, communicate via service or IPs, not localhost, can scale individually so you can add more logger pods without touching web. And for updates, you can deploy one without affecting the other. It is great for zero downtime upgrades. The visual comparison on right side is up perfectly. Multi-container pods are tightly coupled and separate pods gives you flexibility, scalability and better fault isolation. So remember, use multi-container pod when containers are tightly bound and share data or logic. Use separate pods when you need an independent scaling, isolation and updates. Let's see when not to use multi-container pods. Case 1, independent containers. Now it might be tempting to group multiple containers into a single pod just to keep things together, but this can actually lead to a bad design choice, especially when the containers have nothing to do with each other. Here is a rule of thumb. Avoid putting containers in the same pod if they are independent. That means they are completely different job, they don't need to talk to each other, they don't share any data and they serve unrelated purpose. In the diagram here, we see a bad example. An API service and the utility service are forced into the same pod, but notice there is no relationship between them. So what happened? You end up forcing a connection that does not need to exist. This adds unnecessary complexity and tight coupling, making the system harder to manage and scale. A real-world example of this mistake: imagine putting an API server and a random utility tool in one pod. They don't depend on each other at all, so bundling them like this does not make sense. So point to be noted, keep your container loosely coupled unless they truly depend on each other. Don't mix unrelated service just because you can. Let's move on to the case 2. When containers inside a pod have a different scaling needs. This is another common mistake in Kubernetes, combining containers that don't scale the same way into one pod. Here is what to watch out for. One container is resource heavy like application server, the other is lightweight like a matrix sidecar. They need different CPU or memory limits. You may need to scale only one container, not both. But if they are inside the same pod, Kubernetes treats them as a single unit. That means when you scale the application, the lightweight container scales too, even if it does not need to. In the example shown, the app server is the CPU intensive and may need 10 replicas to handle the traffic, but the matrix container, it's light, it's only need one instance. Still you are forced to scale them together. This wastes resources and can lead to inefficient scaling. So, if the two containers don't share the same scaling behavior or resource demand, keep them in separate pod. It gives you more control and avoids unnecessary overhead. Let's look at case 3. When container inside a pod needs a separate update cycle, this is a common issue in a real-world deployments, especially in CI/CD pipeline. Avoid putting containers in the same pod if they are need to be updated at a different times. Here is what unusual happens. Your application container changes frequently, maybe every week or even daily, but the matrix sidecar stays the same and gets updated only once in a while. Now here is the problem. Every time you update any container, the entire pod is restarted. Even if you are just updating the app version from 1.0.0 to 1.0.1, the sidecar, even though it has not changed, gets restarted too. This causes unnecessary downtime or disruption to a container that does not even need an update. A classic CI/CD challenge. Your app container needs a frequent update, but your sidecar does not. Bundle them into one pod force you to restart everything, even if only one part changed. How to fix this? Keep container with independent release cycle in a separate pod. That way you only restart what's necessary and keep things efficient and reliable. Now we have covered when not to use multi-container pod. Let's take a quick look at what's coming up next in this series. First is multi-container pod YAML demo. We will walk you through an hands-on example and show you how to write a clean and efficient YAML files for multi-container pod. You will learn the right way to define the container and their shared resources. Next is volume sharing in action. We will explore real-world example of how containers can share data using volumes. You will see how to configure shared volumes and understand when and why to use them. And then restart behavior. This session will focus on the pod lifecycle, what happens during the restart and how different containers in the same pod are affected when something changes. And finally, viewing the logs. We will look at a practical techniques for logging and debugging. You will learn how to view the logs from each container individually, which is super helpful in the multi-container environment. On the right side, you can see the sneak peek of what the YAML file might look like. And yes, there will be a live demo too. So stay tuned. If this video helped you understanding multi-container pod, hit the like button and share it with your tech friends. Stay tuned for the demo session on this topic and thanks for watching.